drill a center hole. Then they trim the diameter to the required size. Next stop, a computer-guided milling machine. It works on 3 blanks at a time, carving helix-shaped ridges called flutes. The flutes run almost the full length of the blank. Once again, lubrication is essential to prevent overheating. This milling process transforms each blank into a tool. From this point on, the shorter smooth portion is called the shank, the longer fluted portion, the cutting end. Here's the same milling process again, but for a different model. Here are both models, before and after. Now they cure the steel using a 2-step heat treatment process. The first stage hardens the metal using molten salt that's been heated until it liquefies. They soak the tools in 5 progressively hotter salt baths, whose temperatures range from 650 to 1200 degrees Celsius. The second phase of heat treatment is a process called induction. They set each tool into a large metal coil. The coil's internal magnetic field generates intense heat, which softens the shank, making it more flexible. Now the finishing process. They run the shank against a grinding wheel whose grit is made of diamond particles. This gives it the strength to erode steel with a high degree of precision. They verify the final diameter using a digital micrometer. Then a robotic arm runs the tools one at a time through a high-precision automated grinding machine, this time to finish the cutting end. The machine uses diamond grinding wheels to grind the precise cutting angles and finalize the diameter. More complex tools go into this even more sophisticated grinding machine. It too uses diamond wheels and runs robotically. The end mills are now completed. This factory makes high-precision cutting tools primarily for the aerospace and automotive industries, where precision is everything. So at each stage of the production process, the factory verifies measurements using various optical and digital instruments. This sensing probe conducts the final quality control test. It scans each and every finished end mill to ensure that the surface is as smooth as silk. These high-precision cutting tools are now ready to be put to work machining aluminum, titanium, and different types of steel. Around 1000 AD, craftsmen began making intricate window designs using lead rather than wood or plaster between pieces of colored glass. Before long, the church was commissioning stained glass windows depicting religious scenes to adorn the great cathedrals of Europe. You can make stained glass 2 ways. Using copper foil, a technique developed about 100 years ago by the American artist Louis Comfort Tiffany, or you can use the centuries-old European lead technique, which we're about to see. First, the artist lays a plate of glass over a pattern and traces the parts of the design that she'll cut from that plate. Then she scores her trace line using a glass cutter. A quick snap, and the glass separates neatly. She follows the same procedure with different colors and textures of glass for all the pieces of the design. By running the cutter slightly inside the trace line, she leaves room for the strip of lead that will later hold the pieces of glass together. Once she finishes cutting all the pieces, she checks them against the pattern, making sure they fit together properly. Now it's time to assemble the pieces using the pattern as a guide. This zinc molding will frame the panel, its inner groove fitting over the edge of the glass. The artist positions this molding along the perimeter of the pattern. Then she drills an L-shaped wood frame into the work table to hold everything in place during assembly. A few nails keep the molding in place. She'll join the pieces of glass using strips of lead called came. Lead because it's soft enough to bend to the shape of the pieces. After straightening out a long strip of came, she cuts the various lengths she needs to border each piece of glass. The came is shaped in such a way that the glass on each side just slides right under. The cutting pliers, called nippers, are specially designed to slice through the came without deforming it. Once the artist finishes assembling the glass pieces, she pushes everything gently against the wood frame. This squares the panel and ensures the pieces fit together snugly. Now she brushes on flux, a type of acid. This cleans the lead came so that solder will adhere well. Using a soldering iron, she applies a bead of lead and tin solder wherever two strips of lead came join. Then she uses a short bristled brush to coat the lead in black putty. This makes the seams watertight and gives the lead a darker aged look. Finally, she sprinkles on calcium chloride powder called whiting. This sets the putty and polishes the glass and lead to a shine. After 4 painstaking hours, the panel is finished. More elaborate stained glass works feature hand-painted detailing. The artist first prepares a design on paper, then cuts the pieces of glass accordingly. He paints the design outline on the pieces in black, then fires them in a kiln to set the paint. To create shading, he applies a coat of brown paint called grisaille. Using a dry brush, he removes it from the parts he wants to highlight, then he fires the glass again. Now he paints in the final details and fires the glass for one last time. The paint contains powdered glass, so the intense heat of the kiln bonds it to the glass pieces. The result is nothing short of spectacular. For those of you who flunked Truck Anatomy 101, here's a quick review. The front of the truck where the driver sits is called the cab. The back that carries the cargo is the trailer. A semi-trailer is a type of trailer whose front end goes on the same wheels as the rear end of the cab. This type of semi-trailer is called a van. It has a closed-in compartment for transporting cargo that needs protection from the elements. To make the coupler plate, the part that attaches the van to the truck cab, they submerge steel plates in water to quell the smoke that metal cutting generates. They use a computer-guided plasma cutter. This powerful torch ejects hot gas at high pressure, slicing through the metal with detailed precision. Elsewhere in the factory, meanwhile, they take pre-painted aluminum panels and rivet them onto aluminum or steel support posts, the same way drywall goes onto 2x4s in house construction. These thin, lightweight panels will be the van's exterior walls. Plywood on the reverse side, its interior walls. A computerized sensor guides the robotic drills to drive screws through the plywood into the support posts underneath. For heated or refrigerated vans, there's a layer of insulation in the walls. The floor is made of either laminated hardwood or aluminum, screwed onto narrow steel beams. After assembling the walls, the steel door frame and doors, workers install a steel floor plate at the doorway. This protects the floor from damage when truckers load and unload their cargo by forklift. Workers fold aluminum flashing over the roof's perimeter to prevent water infiltration. Fiberglass roofing like this allows daylight into the van. Aluminum roofing doesn't, so those vans sometimes have electric lighting. Another type of semi-trailer is the flatbed, an open trailer used mostly for hauling raw materials such as logs and pipes. Heavier flatbed models are made of thick, higher-grade steel. Workers cut the bulkier parts using what's called an automatic oxycutter. It combines two gases to create a flame intense enough to slice right through metal. Once cut, the parts have to be formed to the required shape. To do that, workers use what's called a press brake, a machine that applies up to 300 tons of pressure to bend the steel. They measure the result to ensure it meets design specifications. The chassis will have two main beams running the length of the flatbed. A semi-automatic robot welds together the various welded sections that make up each beam. A worker follows behind, inspecting the joints and removing welding residue. Now they position those two main beams side by side, inserting steel cross members through them to support the floor. They install the coupler plate and other components, then weld everything together. Flatbeds come in extendable versions designed to accommodate loads of various lengths. They extend and retract on steel rollers operated by controls located inside the truck cab. With the chassis complete, they can now work on the axle assembly. Semi-trailers have an air brake system. When the driver applies the brakes, there's a release of air pressure into the brake chambers, triggering the brake shoes to bear down on the brake drums and stop the vehicle. Once the wheels and suspension system are in place, workers install the axle assembly under the trailer. The average semi-trailer weighs between 5 and 6 metric tons and can haul up to 5 times its weight. A recorder is a type of flute that's played vertically. It consists of a mouthpiece that works like a whistle connected to a tube with finger holes. Mass-produced plastic recorders are a staple of elementary school music programs. Real musicians, though, play finer wooden recorders. The recorder dates back to medieval Europe, though it was likely modeled after flutes from Asia. Back then, recorders were called flutes, and by 1500, they were among the most popular musical instruments. Around 1750, though, the new transverse flute banished the recorder to musical oblivion. It took a 20th century revival of music from the Renaissance and Baroque periods to bring the long-forgotten recorder some noteworthy attention. A recorder is composed of 3 hollow sections made of a lightweight hardwood, such as boxwood. Crafting one section at a time, they find a portion free of cracks, knots, and other faults, then cut away the surrounding wood using a bandsaw. They measure the block's diameter to ensure it's large enough. Then they carefully mark and drill through the midpoint in order to mount the block on a lathe. Precision is critical. The block must be perfectly centered as they round it into a cylinder. Next, they use a large drill to widen the inside hole, known as the bore. They enlarge it enough to insert a tool called a reamer. Then they ream the bore to the final diameter, which varies according to the size of the recorder. The bore tapers slightly toward the bottom of the instrument. The cylinder, now a tube, goes back on a lathe. The smooth pencil line means the bore is straight and the tube is centered. They trim the outside to reduce it to the right diameter, checking the measurement with the help of calipers. Then it's back onto a lathe for the final profiling. This is where the maker gets to flaunt his artistry. embellishing the tube with ornamentation typical of the Baroque period. From raw wood to this decorative stage, it takes about an hour and a half to cut and shape the recorder's 3 sections: the head joint, the middle joint, and the foot joint. Now they smooth the surface of each joint with fine sandpaper. Then it's back to the technical tasks. Locking the middle and foot joints in a vise, they drill the finger holes, 7 holes down the front and 1 in the back for the thumb. For the recorder to play in tune, they must follow the precise measurements specified in the technical drawing. In the head joint, they cut a flat canal called the windway. It directs the air that's blown into the instrument. Next, they carve out a rectangular window with a sloped opening called the labium. The labium is what regulates the recorder's tone, the sound quality, so its size and angle are critical. The air the musician blows into the mouthpiece travels down the windway and hits the sharp edge of the labium. This creates a whistle effect thanks to a block of wood closing off the top of the instrument. They use cedar because it never rots, despite years of hot air and saliva blowing on it. They complete the head joint by beveling the top. This forms the mouthpiece. Now they glue a thin layer of cork around all the joint ends. This creates a snug fit when the instrument's assembled. After testing the recorder's tone and tuning, making adjustments to the workings if necessary, they stain the wood, then wax and buff it to a shine. Recorders have a 2-octave or 60-note range. They come in about 15 different sizes. The longer and wider the instrument is, the lower its register. The shorter and thinner it is, the higher the sound it produces. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net. The How It's Made crew vehicle is courtesy of Subaru Canada.